Okay. So last time, if you remember, we were talking about the event and event handlers, and then the listeners for those events, if you remember. And the example that we were dealing was the push counter example, where we had the button to click, and then we were, as a result of that, generating a counter incremented by 1. So if I go back to that example, if you remember, we had the push counter panel class, which we had the constructor for, and then we have a count integer, which is an instance variable of this. So this is indicated here, private int count, it's instance variable. And then another instance variable was the button, the push button. Again, it's a Swing library object. And we have a JLabel, a label to indicate what the last value of the counter is. So obviously, whenever you create the panel, it is going to execute the constructor. So it will initialize your counter to be equal to 0 for this object. And then it is going to create this object, the button, with the label push me. So it's going to have a label on top of the button, push me, in order to indicate what's going to happen when you click it. So we have an action listener, which is going to basically listen to what happens with the mouse click. So that's what's going to happen. The button listener will indicate what we are going to be doing with that button click. And if you look into this, this is another class, which we mentioned it was an inner class, meaning that it is part of this class's definition. And we have also another label, which we just create, allocate its space, and then have the text pushes plus whatever the current count value is. Initially it would be obviously 0, so pushes 0 will be the initial thing, and we add those two things, the button and the label, one after the other one, and set the size and the color accordingly. So this was the constructor for our push counter panel. And if you remember, this was the button listener, which is an interface, which is an implementation of an interface, action listener. Again, we will cover the details of how interfaces operate and what they do. But basically, what it does is that it implements all the methods defined by the action listener. Action listener only gives what will be the return type, what is the name of the method, and then the arguments it takes. So it will only list all those methods that if a class implements it, will have. So in this case, there's only one method within this action listener, which is basically action performed, does a void return type, so doesn't return anything. And then you have an event that is passed as an argument. So based on this event, what action it is going to perform is indicated, as in this method call it is mentioned here. Counter is incremented by 1, and then the label's text, the object's label, is updated with the new count value. So pushes plus whatever the count is will be the label of the new text. So again, if you look into here, this is part of the class that we just defined. Why do we have a private definition here? Since it is an inner class, it will only be used within our current class, which we don't need to define publicly. So we can just allocate a private modifier for this class. So that's why we have private modifier indicating this class's definition. So we call this action performed method whenever we create it. We create this class, new button listener. So we generate the method, and after we call it, it is going to just increment the counter by 1 and then update the label on the screen. So if we go back to the push counter Java. So if you remember, it just basically, what it does is it creates the frame, puts the panel on top of the frame, and then sets it to the correct size, and then shows it on the screen. So if you just to recall how it was operating, if you run this, it just has the button and then the label printed right next to it. So whenever you click it, it will update the corresponding value. So the two important things here is that you have to be aware of the event, which is in this case a button mouse click, and then the second one is the listener, where it listens to the activity. Whenever this happens, it will update the text that's appearing there. Any question? So the other example we have is related to text fields. If you recall, I think we started this also, right? The conversion from Fahrenheit to Celsius. We have seen it? No? Yes, we have seen it? Okay. So if you recall the Fahrenheit example, I'm just going to skip these slides because we have seen it before. If you go into the text field slides, we have the Fahrenheit.java and Fahrenheit panel.java. Again, they have listeners and then corresponding events. So let's open that up. Fahrenheit.java and then Fahrenheit panel.java. Again, we have here in this case, if you look into this, we have the three labels which are the instance variables of our class: input label, output label, and then the result label. And then we have a JText field which is called Fahrenheit in this case. And whenever you create the object, the Fahrenheit panel, you call the constructor, and then you create those three labels, which is just going to have the enter Fahrenheit temperature, and then it will have a box there, and we have the temperature in Celsius, and then the result label. As you can see, Fahrenheit is initialized to have a JText field. Again, it's a Swing library object, so you create that object with obviously, what does 5 indicate? The spaces that's allocated, that's available for you to type in. So it's just going to convert whatever that there's present. It is going to convert them into the integer values. And when you look into the add action listener, so it is going to listen to what happens with this temp listener object, which we just create with new temp listener. So we are going to be creating the object, and as we will see below, again an inner class, temp listener, again implements the action event, action listener, and then we have the same method that we need to implement internally. When you look into the implementation, you see that we get the Fahrenheit. If you remember, that was the JText field, which we extracted text entered by the user. We extract that text, and then we convert it to the integer value with the parseInt method. This was, if you recall, a static method of integer class, and then we just give the text as the argument and then generate the corresponding integer value and convert it accordingly. And just print the result based on this conversion, again, through a static method where you have the toString method called and convert it to the corresponding string value to update your text on the screen. Again, we have done this, so it's same exact thing with the frame. We create the frame, and then we add the corresponding Fahrenheit panel and just set the size, initial size, and then show it on the screen. So I'll just redo this exact same thing on the screen, what we did before. So if I just, initial value, if you recall, was, this is the result label, and then it is updated based on the value entered here. If I enter 1, 2, 3, when I hit the enter key, this generates an event, so it calls the corresponding listener, and then when this event is activated, it performs the math calculation and then generates the corresponding Celsius value and updates the text accordingly with the setText method, if you recall. Any question? So this is something we have done already in the last lecture. I just briefly went over it. Okay. So we're going to start dealing with chapter 5, which is going to be, again, kind of a review, but I will go a little bit faster because you have seen most of the stuff in CS 101. And it's going to consider conditionals and loops and the implementation details of those. We will be, going a little fast. If you see something you don't remember, you don't understand, you don't recall, you can just raise your hand and ask a question about it. So feel free to ask if you don't understand. So as we all know, any program is written using certain decisions. These are, performed by Boolean expressions most of the time. So you need to have a condition to generate a certain statement. And this is basically what we do is conditional statements are the things that we use. And in general, if you look into any programming language, you have to have these statements in order to perform certain tasks. When you look into chapter 5, you see Boolean expressions, conditional statements, how to compare data, the loops that repeat statements, iterators, and then additional graphical objects. Actually, the first part of the chapter 5 is something you should already be familiar with. So the rest of the graphical components are the things that you may have not seen before. So please, raise any concerns you may have throughout the class. So when you consider the flow of control, what is flow of control or control flow? It is basically the execution of the program. So normally, if there's no conditional statement or loop or anything like that, what happens is that you have a sequential control flow. So if you have a statement executed, another statement is executed afterwards, another one afterwards, and so on. So it normally goes in a sequential fashion. However, if you have, for example, an if statement that indicates a certain condition, it's going to execute this, else it will execute this one. So it is going to change its control flow. So where you will see that instead of going here, you might also prefer going there too, based on the condition. So this is called control flow. And normally, again, it flows in a sequential fashion from one statement to the other one. However, if you have if, else, switch statements or loops that are going to take you back to the top of the loop, those kinds of things will change the flow of the control, but the regular control flow will go in a sequential fashion. This is called the control flow. So in any programming language, you have to have this control flow follow a certain pattern. So conditional statements, as you remember, you have an if statement, if else statement. Anything else? Any other conditional statement in Java? Switch case statements are also conditional statements which we can write. So if statement, if you recall, has a condition that you check if this condition is true, you do execute this statement. Otherwise, you will continue with the rest of the control flow, which is going to continue with the sequential instruction. The condition may be a simple condition such as a Boolean value, true, false, or a complex expression that you need to evaluate and generate. So if a reserved word, then I will skip that. If the condition is true, we execute. So graphically representing, condition is evaluated. If it is true, we execute the statement. Otherwise, we will just skip it if it is false, as shown in the diagram. When you look into the Boolean expressions, we usually use either one of these operators to understand certain conditions. Equal to, note that this is not equal sign assignment operator. It is checking whether it's equal to. And then not equal to, less than, greater than, less than or equal, greater than or equal. And as we will see, we will make a lot more complicated conditions using these operators. So for example, what we do is we first check whether this condition is true. If sum is greater than max, we are going to update the delta according to this sum and max value. And at the end, we will print the sum. So based on this statement sequence, are we going to print out in any case, or are we going to only execute if the condition is true? So this system out print line, is it going to be executed if this condition is true or anyway? It will be executed anyway, because if will only apply to the first statement. If you wanted to do that, you would obviously want to have a block statement which has curly brackets and taking all these two statements into one block statement, right? So you have to be careful with that. And age.java, let's see that. So this is going to be a basic example for you, but I will just show it. So when you look into the main method, we have a constant value final int minor 21, and then it is going to create a scanner which is just going to take from the system in, which is the user input from the keyboard, right? Whenever you enter, it is going to take them one by one according to the method you use. And as shown here, you use the next int, so it is going to look for an integer value and try to scan it. Whenever it finds it entered by the user, it is going to copy that value into the age variable. And you have, you entered age, so it will be printed on the screen. Obviously, if age is less than minor, youth is a wonderful thing, enjoy. And then for others, for everybody else, it's going to say age is a state of mind to make everybody happy. So I will just skip this and continue. Indentation, as we all know, indentation is something you always care while you're writing your code, because you would like the reader or programmer to understand what is actually meant by your program. Even if you go back to your own codes, own programs, you may find yourself not understanding easily if you didn't do correct indentation. So indentation is important. As it is said here, always code as if the person who ends up maintaining your code will be a violent psychopath who knows where you live. So you should try to be as careful as possible in indentation, because it is for the user to understand what is meant underlying in the underlying code. So you can come up with a lot more complicated conditions, such as this one. It's basic actually. You add the stock and warehouse and compare it with the total value. If they're not equal, you generate the condition true, otherwise it will be false. So any kind of condition you can come up with is fine. However, you have to obey the precedence rules. That's important part. For example, in this case, the conditional operator, the comparison operator, is going to be less prior than the arithmetic operation. So you have to first wait the result of this in order to do the comparison, right? If you didn't follow and you tried to compare this first, total not equal stock, and get a result which is going to be a boolean, and try to add it to the warehouse, obviously it's going to be a false execution, right? In languages such as C, it is the binary values true and false are represented as 0 and 1, not like true or false. You can also use true or false, but in those cases, execution in that manner would result a wrong result, because it's going to generate either 1 or 0 from here and then add that result to the warehouse. However, as you know, in Java, booleans are represented only by true and false, not by 0 and 1. Logical operators, if you recall, we had the logical not, logical and logical or. This is a unary operator, meaning that you have only one argument to your operation. So as in the example of, let's say if I have a boolean variable a, then I will have not a as given like this. That's why it's unary, so there's only one argument to it. If you consider the logical and logical or, they're binary operators, meaning that you have two arguments or two parameters that you're using. So as in the case of A and B, or A or B. They have Boolean operands. When you look into the execution, they will result in a Boolean value as well. So we all usually represent things using a truth table. In also digital design, if you're going to take it, you will see a lot more complicated truth tables than this. When you look into the value of A, true and false, not A obviously will have the opposite of it, or negation of it, which is false and true as well. So as you all know, AND operates. If both of them are true, the result will be true. If one of them is false, you will get a false result. In OR, if both of them are false, you'll get a false. If one of them is true, you'll get a true result. So the table will be obvious for this too. So you can come up with a lot more complicated conditions as this one. So you check first total less than max plus 5. So you're going to first add max to 5, get the result, compare it with the total, and get a Boolean condition, true or false. and then you have the true or false value found. It's a Boolean variable, must be a Boolean variable. And if it is true, this whole thing will be false, and then you will make an AND with that. So you can, if you're given a complex, complex Boolean expression, you can come up with the whole truth table by looking into individual arguments of the condition. So as in the example, you have A and B, corresponding A and B, and A or B values are listed and shown here. I'm just going to skip this slide as well. So when you look into the specific expression that we would like to evaluate, as in the previous example, we had a total less than max plus 5 actually, and then you have AND not found. You can list all things here and then generate the overall truth table. If you're not certain about a result of a certain statement, you can just divide it into simpler parts and generate it by yourself. Okay? Sometimes it might be helpful, because if it's a complex Boolean expression, you may find it hard to understand how it is going to behave in the end. So short circuit operators. What does short circuit mean in Boolean expressions, if you recall? Exactly. So short circuit means if, for example, consider the AND operator. If I have, let's say, A less than 5, and let's say I have, or A not equal 0, all right, and then max divided by A is greater than some value, X, let's say. So if these are the two conditions that I'm checking, what it is going to do is it will first check the first condition. If this is true, then it will continue to evaluating the second condition. Otherwise, if this is false, we know that if one of the arguments of the AND operator is false, the whole thing will be false. No need to consider the rest. What is the advantage of this? You will save time, so you don't need to execute. If it is a really complex execution here on the second condition, you don't need to go and evaluate that, so you can just skip that part immediately if you see the first thing as a false. And also, it also is helpful if you have, in this example, if A is equal to 0, for example, this will not be evaluated, which will prevent me to, dividing by 0. However, if it was not a short circuit operator, in that case, I would have first saw that it is not equal to 0. It is equal to 0 to false, and then I will try to evaluate this one as well, which is going to give me an error, divide by 0. Right? So it's going to, this kind of short circuit will prevent those errors. When you look into this example, how do I prevent it to be a short circuit operation? Do you remember? What do I use for non-short circuit operations? I use only one of them, right? So if I use it like that, it is, in that case, it will be not a short circuit, but it will evaluate both left and right hand side. Okay? Similarly, you have the same thing with the OR. However, in OR, obviously, you will not care about one of them is false, but rather you will check the first one. If it is true, right, then you don't care about the second one, because it must be true since one of them is true already. So in this case, short circuit with an OR will be checking for a true. And if you don't want to use a short circuit one, but rather a regular OR operation, again you will use one OR in that case. Any question? So this example is actually showing what I was trying to say. If count is equal to 0, you won't go and execute this part at all. So divide by 0 will not happen. However, if it is not equal to 0, then you can safely divide total by count easily. So if else, this is again should be an easy thing for you. If condition, you execute statement 1, else you execute statement 2. so that you have a second option if the condition is not satisfied. So if you want to see the wages application, let's go ahead and see that application. Wages.java. When you look into this example, you see that it has two constant values, rate 8.25 and then standard equals 40, and you have again a scanner, scan new scanner, so it takes a user input from the keyboard, and then you initialize your pay to be equal to 0, enter the number of hours worked, and then you read the integer value by scan next in, so you're going to get the value from the user, and you start executing these lines of code. And what do we do next is that if hours is greater than standard, so the user entered hours is, if it is more than 40, which means he worked overtime, so he needs to be, paid for overtime hours. And when you look into this, it first multiplies if hours is greater than standard, meaning that if it is greater than 40, you will get for the first 40 hours whatever the regular wages, and then on top of that, for the overtimes, which is hours minus standard, let's say if the guy worked for 50 hours, for the 10 hours he's going to get a 50% extra for the Mesai hours, right? So he's going to get additional bonus money for that. And otherwise you will pay, if the hours is less than 40 for the regular hours, then you'll just pay whatever he should be getting. So the one thing to note here is that you have FNT format pay, so the amount that you're going to pay will be printed on the screen based on the current currency instance, which is basically set to by default to the US currency, which is just going to have a dollar sign at the beginning, and then it will have 2 digits after the decimal point, right? So as you can imagine, graphical representation follows the same path. Instead of a false going into the regular next instruction, it just executes the statement 2 in the if-else case. You can perform any nested type of ifs and elses to get whatever you need to do. Let's see an example, coin flip and coin Java. So if you open up these, you see that coin flip mainly has, the main method has an object that is created, my coin, type coin, which I will just briefly show in a few minutes in coin.java. You create this coin object, and then there's a flip method. So you flip the coin, and then whatever you get, you print that on the screen, right? And if my coin is heads, there must be a method which returns a boolean true or false. If my coin is heads, if it is true, then I will say you win, otherwise better luck next time. So this is the basically running running class for the coin. And then if you look into the coin class, public class coin, so we have the 2 constant values, heads and tails equal to 0 and 1, and you have a instance variable, face, whatever the face value is. The constructor, whenever you call the object, whenever you create the object, it's going to call the constructor, and then it will call its basic flip method to assign an initial value. So it will flip it whenever you create the coin along with the creation. And the flip, obviously you can imagine this too. You use a match random to generate a random number, and then multiply it by 2 to get either 0 or 1, so that you have the face value based on a random result. Boolean is heads, so it's going to return a Boolean value if your face value, the current face value, is equal to heads, which is 0, right? Heads was 0. Then it's going to return true. If it is 1, it will return false. Any question? The toString method will be called whenever we use the object in a string, right? So if I say system out print line and then a coin object, as we did in the example, it is going to call the toString method, which returns a string. So I will have a face name string and then check whether face is equal to heads. If it is equal, then I will print heads on the screen. Else I will print tails on the screen. And then this will be the string returned by my toString method. Again, just for those of you who don't actually remember or understand this, whenever you write the object, as in this case my coin, in a string location such as this one, so system out print line accepts strings to print on the screen. If you give the object's name, it automatically calls the toString method, right? So whatever you put in the toString method will be called here. This will also apply to string concatenation, or wherever you need string. If you use the object's name, toString method will be called.
What if you write my point dot toString method to write the same thing?
Yes, you can directly write myCoin.toString. You can call it as well, but if you just give the object's name, it is automatically going to call, if it requires a string, toString method. Okay, the toString method will be automatically called whenever you give the object in a string argument. Okay. Any question? It's not clear, or?
But does it show if I call my coin.string without system out, does it show it on screen?
It is going to just generate a string. If you look into the method call here, you see that it only returns a string. So it will just return a string. If you use it to print on the screen, it will print. If you don't, if you assign it to something, you can do that, but it's not just going to print it if you don't say system out print line anyway. But what I mean is that whenever you say system out print line and put my coin, although you didn't say my coin toString, it will automatically understand that, hey, the guy or she needs to write it on the screen, then it will call the toString method automatically. That's what I'm trying to say. Any question? So indentation is important, but it's only important for the human being, for the person who is writing or who is reading or who is trying to understand what's going on. It doesn't mean anything to the compiler. Compiler doesn't care if you put one more tab less or anything like that. Compiler doesn't care. What compiler cares is the rules that the language employs. So in this case, even though the programmer probably meant to have all these things into one block of statement, it's not going to happen like that. For every iteration, it's going to increment error count by 1, even if this condition is false. So you should be careful with indentation. It's only for human beings to see and understand what actual programmer is trying to write. So block statements, as I said earlier, if you want to execute both of them at the same time with the condition, you have to put them into curly brackets to be able to execute it. So again, you can use it with the if-else, and in different forms and formats you can implement block statements. So guessing.java, let's see the example there. So when you look into the main method, you have a constant max set to 10, and then you have an answer and a guess, integer values. You create a scanner from the user and then get the input from the user based on that. And if you look into here, this is something you may have never seen before. So you have a random, which is a random class generator, new random. So generator is a random number generator, which is apart from the mathRandom class. Okay, so you can use this as well. Basically, mathRandom class is kind of pseudo random number generator, which is not exactly random all the time. If you have, thousands of iterations going over, it may end up generating the same numbers at the end. So mathRandom class is not really used for random number generators if you purely need random numbers, because they use a specific function to generate the random, which uses a seed value, and at the end you end up getting not really random numbers. So that's the problem, and they have created a different class with various seeds according to the timing. Actually, the time of the execution, whenever you execute it, it automatically uses another seed value, so that it's purely random in that case. Okay, that's why they came up with this random class, and it has certain methods. You can generate integer random numbers or real random numbers. Different versions of the methods are available, so you can use them. However, in this case, it is generating the integer random. So what it does is that generator, again, it's a random class object. So it generates the integer next int with the next int. Generator generates a integer random number, which is limited by the max value. So if you remember, the math random class generates in the range of 0 to 1, right? Normally. But in generator, you can generate an integer automatically by next int method. So it's going to generate a number that is between 0 and max. So in this case, what it is used for is that it's a simple guessing game. Let me execute this. Okay, we need to compile. Execute. So I'm thinking of a number between 1 and 10. Guess what it is? Let's guess. 5? 8? That's not correct. Sorry. The number was 7. So we're not lucky. And when you look into this, I'm thinking of a number between 1 and max, which is set to be 10. Guess what it is? And then you guess something. It is read by the program. So it guess now has the value. If guess is equal to answer, then you print that you got it, good guessing. Otherwise, it's just going to print the guess was not correct, and then the number was this. In this case, what is it going to say? What do you think? Is it checking for anything like what is entered by the user? No, so it shouldn't check for that, and eventually it will, always get this else part, because it will never be equal to the answer, because answer is limited by 10, so it will just say you didn't guess correctly. Obviously, if you wanted to check for that, what would you do? So you would have a do and while loop here, indicating that until the user enters a correct range value between 1 and 10, you reiterate and ask the user, hey, enter a correct number, enter a correct number. Until he or she enters the correct number, you will continue. So the conditional operator, anybody remembers what this conditional operator is doing? Ternary operator. Does it ring a bell? Ternary. What does ternary mean? Unary, binary, ternary. So you have three arguments to this operation. So what that could be then? So there was a statement which you could use with a question mark, if you remember. So I had, let's say, A greater than B. And then, is it true? If it is true, I select A, for example. False, I will select B, right? So what this basically does is, if you recall, this is a conditional operator which checks for a condition at the beginning. If it is true, it chooses the first statement. Else, if it is false, it chooses the second statement. This is exactly like writing if A is greater than B, execute A, else B. So you could say that, let's say this is A is greater than B, true. Okay, then larger. Larger is equal to, if A is greater than B, larger will be equal to A. If larger is less than, A is less than B, larger will be B. So in this case, it is going to be something like this. Larger equals A, else larger equals B. So this is exactly same as writing it as a if-else or implementing it like that. Okay, so this is called conditional operator, and it's called the ternary operator because you have three parameters that are using in this operation. So the syntax is condition, check the condition. If true, expression 1. If false, expression 2. So in this case, the exact example I just wrote on the board. If number 1 is greater than number 2, you will assign larger to number 1. Else, you will assign it to number 2. Again, these are statements, so you can have any statement that you like instead of this number 1. So you could say A plus B for the first part, and then A minus B for the second part, if something like that you needed.
Hocam large'ı initialize etmemiz gerekiyor mu peki burada da? Hani yukarıda.
We assume that it is defined earlier, but it doesn't have to be initialized. So, but you must have int larger already defined as an integer. So another example with the ternary operator, if you look into this, system out print line, and then you print your changes, and then it is going to copy whatever that integer value is. Remember, if you concatenate a string value with an integer, it automatically appends this integer at the end of the string, right? So it's going to concatenate your changes. Let's say count is 5. 5 plus, it's going to concatenate this part too. What is it going to concatenate? It's going to concatenate based on if this count is equal to 1, it will concatenate dime. So the whole thing will return dime. Otherwise, if this condition is false, if it is plural, it is going to go with the second option, which is dimes, and it is going to append it as if it was coming after this plus sign. Okay? So you can use this in any where possible that is implementable. You can write that. Any question? So nested if statements. As we have been using if statements in any conditional operation, you could, add multiple levels to it and use it for that purpose too. Let's see this min of 3 example. So when you look into this min of 3 example, you see that it's a class with the main method. So you have 3 numbers, number 1, number 2, and number 3. And then I have a minimum value which is initialized to equal to 0, right? So I get the system input from the user, whatever that is, and I will enter 3 integers. So I will read those 3 integers one after the other one. And then I will compare and find the minimum of those 3 integers. So what do I do is I check if number 1 is less than number 2 and also it is less than number 3, then this must be the minimum, right? So I will say minimum is equal to number 1. Else, if number 1 is less than number 2 but it is not less than number 3, then number 3 must be the minimum one. So I set minimum to be number 3. And then obviously if this first condition is wrong, so it's going to go map into this one, it is going to choose this branch, and if number 2 is less than number 3, minimum will be number 2, and the last part will be else minimum will be equal to number 3. Can you convert this into can you write this in a different manner? How would you write it? You could have combined these conditions into one, such as if number 1 is less than number 2 and number 1 is less than number 3, have it as a single condition, such as if number 1 less than number 3, right? And number 1 less than number 2. If those two conditions satisfy, I can say that minimum is equal to number 1. And so you can come up with all the other conditions and write it one by one. But this is in a sense a neater way of writing it. One thing to note here is that I will come to this point again, but just to remind you, else's map to the closest if statements. This is important. So if you look into this else, which if it is going to map into? So it is going to map to the closest else. So closest if So it's going to go into this if. This else is going to map to this if, because this one will be mapped to this one. So let's say if I have a statement saying that if, and then I have another if, and then I meant else here. Which one is going to be executed? Let's say this else condition is checked. Which one will be executed? So if I come to this else, this means this is the else of this if. Right? So it is going to actually matter which one, it is going to map. Your indentation doesn't matter. So you have to be careful with these kinds of else's. If you need to specifically mention that I'm going to use this else with this if, you would have put curly brackets, right, indicating that. So you would have put it like that, so that it means I mean this else is this if's part. Okay? So this is important, and again I will come to this again in the coming lectures. Okay, let's give a break and we can continue afterwards.